Hey Mr. Ferrante, it's Andy, and today I'm going to be rationalizing the denominator. So this is the problem I have. It's x to the 1/2 powered times, or over, x to the 2/3 powered times y to the 1/3 power. So, since they're all in fractional exponents, that's the same thing as a radical pretty much. So we can't have that in the denominator. So what we're going to have to do is multiply by another radical or fractional exponent to get the radicals out of the denominator. So basically, the easiest way to do this, I think, would be to just keep it in fractional exponent form and multiply by x to the 1/3 power times y to the 2/3 power over x to the 1/3 power times y to the 2/3 power. So multiplying by 1 basically. And you see, after we do that, the 2/3, since they have the same base, you can add, so that x to the 2/3 plus x to the 1/3 would just equal x, and y to the 1/3 times y to the 2/3 would just equal y. So then after doing that, we get just an xy in the denominator. So basically, we rationalize the denominator, but we still have to simplify what's up top. So when we look at this, we have x to the 1/2 plus x to the 1/3 times y to the 2/3. But we're going to have to find the least common denominator. And we can see that the least common denominator is going to be 6 in this problem. So we have to multiply by 1 in order to get a denominator of 6 for the powers. So we'd multiply 1/2 by 3 over 3, 1/3 by 2 over 2, and 2/3 by 2 over 2. Which then leaves us with x to the 3/6 plus 2/6 times y to the 4/6 power over xy. And then after adding those up, we get x to the 5/6 times y to the 4/6 over xy, which then can be simplified even further into a radical. And since they have the same index here, because we found the least common denominator, we can just go ahead and throw the bases back under the radical with the exponents. So we get the sixth root of x to the 5th times y to the 4th over xy.